Okay, so next, let's talk about the graphs and how to interpret the line behavior of these graphs in applications. So scientists, engineers, medical professionals, and anyone for that matter is truthfully interested in the relationship between two variables. So for example, if one uses more or less cologne or perfume, does that person get more or less yeses when they ask someone to go on a date or to go get coffee? Uh, if someone increases or decreases the processing temperature of a ceramic, does that increase or decrease the properties of that ceramic? If someone increases or decreases the dosage of a medicine, does that increase or decrease the hospital stay of the patients, etc.? So people are interested to find out if there are linear patterns or linear correlations between two variables. And there are three general linear patterns or linear correlations that are of interest. So one, when you plot what's called a scatter plot, which are a bunch of ordered pairs, those ordered pairs will have a linear trend. And so here we've got a linear trend with a positive slope. So as x increases, y increases. So as x goes up, y goes up too. And so an example of this would be as the amount of cologne or perfume I apply increases, the number of yeses increases. So the more perfume and cologne, the more yeses. Okay, so that would be interesting to know. Or we can have what's called a negative slope. So here we can see collected data points going down and to the right. Well, as we saw, that's called a negative slope. So as x increases, though, y decreases. So as x gets larger, y gets smaller. And so that relationship would look like this. So as the amount of cologne or perfume I apply increases, the number of yeses goes down. If we collect the data and there doesn't appear to be any linear pattern at all, okay, a scatter plot looks like scatter shot. Okay, that's an example of zero slope. And so as x increases, y does not appear to change. So this would be an example of there being no correlation between two variables. So let's look at this example. So this is looking at the equation for Fahrenheit and Celsius. It's used to convert Celsius degrees to Fahrenheit degrees. In July 2022, large areas of Europe were feeling temperatures of 40 degrees centigrade. Water freezes at 0 degrees centigrade and boils at 100 degrees centigrade. So graph this function and interpret the slope and the y-intercept. Okay, so we have this equation which gives the relationship between Fahrenheit and centigrade. So you can see that this is already in slope-intercept form. So the y-intercept is 32, and the slope is 9/5. Now we're dealing with temperatures centigrade, of about 100 degrees from 0 to 100. And we're going to look at a temperature of 40 degrees, which is kind of in between. So we're going to create a Cartesian coordinate plane where the x-axis is going to go from 0 to 100, and the y-axis is going to go from 0 to maybe about 240. So let's make that. Stop moving on me. Okay. So let's try and sketch this here. So I'm going to do 10, 20, 30, 40, 50, 60. Oops. doing my best to keep these evenly spaced. 70, 80, 90, 100. And so this axis is going to be degrees centigrade. So this is my independent variable, which is usually where the x-axis is. And on my vertical axis, that's the dependent variable. This is going to be degrees Fahrenheit. And I'm going to label this in increments of 30 instead of 10. So I've got 30, 60, 90, 120. It's a little bit big. 150, 180, 210, 240. There we go. Okay, not too bad for a sketch. So we've got a y-intercept of 32 degrees. So 32 is right here above 30. All right. Now we know from this y-intercept, we can do a rise of run of 9/5. So the slope is equal to 9/5. But on these scales, it's really going to be hard to kind of rise 9 and go over 5. Instead, what we can do is we can multiply top and bottom by 10. And this is 90/50. It's still the same slope because all I did was multiply this by 1. And so now if I go up 90, if I rise 90 and run 50, that's going to be easier to graph on this coordinate plane that I've made. So we're going to go up 90, which would be 92 here. And then we're going to go to the right 50, which is right about here. So I'm going to use like some dotted lines here to plot my next point. And then we could go up 90 again. So a little over 180. And then 50 over to 100. Again, I'm just doing the best I can because this is hand drawn. Not too bad. Okay. A little wonky, but all right. So this is the line. This is the graph for F degrees Fahrenheit is equal to 9/5 times degrees centigrade plus 32. Now, most of us, in the United States, we don't think in terms of centigrade. We always think in terms of Fahrenheit. So, here water freezes at 0 degrees centigrade. So here we've got degrees centigrade and degrees Fahrenheit. And so we've got 0, 40, and 100. And so 0 is when water freezes, and 100 is when water boils. And then 40 degrees centigrade was like a record high temperature in Europe. So how many degrees Fahrenheit is 0 degrees centigrade? Well, we know right here is 0 degrees centigrade. And so the y-intercept is actually the degrees Fahrenheit. So it would be 32 degrees Fahrenheit. So 32 degrees Fahrenheit is 0 degrees Celsius. Now, if we look at 40 degrees, okay, if we go up from 40 till we hit the line and then we move over, okay, we see we should get some number that's less than 90. Looks like it's hitting the y-axis less than 90. All right, but how do we calculate that exactly? Well, we plug 40 into our formula. So we have F equals, so let's say here, degrees C equals 40. So F equals 9/5 times 40 plus 32. 5 goes into 48 times. 9 times 8 is 72 plus 32. Looks like I was wrong. That's going to be 104. So it looks like maybe my graph is a little off. Oh, I know why. Okay, so this helped me find an error. Okay, so degrees Fahrenheit is going to be 104. Okay, so what did I do? I did some math in my head. That's the problem. Because 30 plus 90 is about 120. And where did I put it? I put it at about 90. So this point is wrong. And that means this point is wrong. Okay, this happens. All right, so we'll fix it. Okay. So if we go 90 up from 32, that's going to be 122. That's this point. And then we'll come over here to 50. All right, and that's our point. And then if we go 90 up from 120, that's going to be a little over 210. And then up from 100. There we go. Maybe that's why my graph looked like it was off. It's because I didn't do addition right. Fixed it. Okay. So now if we put 40 in for X, hit the graph, and then go over, now we should get a value greater than 90. All right. So graphing this helped us find a mistake in our graph. Okay. How about 100? So if the, gotta wait a minute. If the degree centigrade is 100, then Fahrenheit is equal to 9/5 times 100 plus 32. 5 goes into 120 times. And 9 times 20 is 180 plus 32. And that's going to be 212. And so when degree centigrade is 100, degrees Fahrenheit is 212. So water boils at 212 degrees Fahrenheit and 100 degrees centigrade. And if we look over here at our graph, when we had 100 degrees centigrade, we were just over 210 degrees here on the vertical axis. So, this is how we can graph a linear equation using slope-intercept in an applied way, and be able to use it in order to like in this example, convert temperatures from centigrade to Fahrenheit. Okay.